All right, so in the last video for Unit 3, we're going to take what we learned about inverses and apply that to solving equations. So we've learned 5 different methods using Cramer's rule, using elimination, substitution, graphing. Those are the other 4. This is method 5, how to solve a system using using inverse matrices. So if you might look at this and say, well, how is this a system? Well, number 1, for example, I'm just going to put it up here so we have a little bit more room. Number 1 is representing the system negative x plus 3y equals 0, and 6x, that should be a minus right there, 6x minus 8y is equal to 30. So you can probably see that kind of the similarities there. These numbers, the negative 1, the 3, the 6, and the negative 8 are the coefficients, and the 0 and 30 are the answers. So that's how you represent a system. Number 2 is just a pure matrix equation, not really representing the types of systems that we're used to seeing, but I'll show you how to do that as well. Okay, so there's really only 2 steps. There's a lot of smaller steps as part of this, but the 2 main steps are to find the inverse, which we already know how to do, and then to multiply both sides by that inverse. And I'll explain why we use step 2. Okay, just think back to one of the more basic equations that we did early on. Let's suppose I asked you to solve that equation right there. And the basic rule in algebra is you see what's being done to x and you do the opposite. Right in that equation, this one right here, x is being multiplied by 3. So if I want to solve it, I need to cancel that out by doing the opposite. And the opposite of multiplying by 3 is dividing by 3. So those will cancel. And then, of course, whatever I do to one side, I do to the other. It's the same exact idea here. The opposite of multiplying by a matrix is not dividing by a matrix. It's multiplying by the inverse of a matrix. So that's what we're going to do. We need to find the inverse and then multiply both sides by that inverse. So first thing is I'm just going to call this matrix right here, I'm going to call that matrix X. We can call it whatever we want, but let's call it X. So I need to find out what is the inverse of X, X inverse, which we'll symbolize right there. And if you remember, it's 1 over the determinant, and then we switch the first and negate the second diagonal. So first of all, the determinant is going to be negative 1 times negative 8, which is 8, minus 6 times 3 is 18. So 8 minus 18 is negative 10. And that's going to be outside on that inverse right there. Okay, then we need to switch the first diagonals, so negative 8, negative 1. And then secondly, we need to negate these. So that 3 becomes a negative 3, and that 6 becomes a negative 6. This right here that we just found is x inverse. It's the inverse of x. Okay, now what do we do to actually solve this? What we need to do is see what's being done to this A matrix right here. And by the way, A symbolizes a matrix. We don't know what it is yet, but we'll find it. See what's being done to that and do the opposite. Right now, it's being multiplied by x, and the opposite of multiplying by x would be multiplying by the inverse of x. Okay, these are going to cancel each other out. An inverse and its matrix, or a matrix and its inverse, remember that equals the identity matrix. And anything times the identity matrix equals itself, meaning that we're just going to be left with A right there, which is what we're trying to find. And then whatever I do to one side, I have to do to the other, so I have to multiply x inverse by this 0, 30 matrix as well. And notice that I put x inverse, or I meant to put it on the left side right there. And the reason I meant to put it on the left side is because order does matter for every matrix multiplication except for this one right here. Only when I'm multiplying inverses does it not matter, but it does matter for everything else. So now I don't really need to multiply this left side. I already know that these are going to cancel. I already know that A is going to be left over. I only need to do this part right here. I need to do x inverse times 0, 30. And let's come down here to do it. This right here is x inverse, and I'm just going to put 0, 30 right next to it. Okay, first thing is I'm going to leave this negative 1/10 to the end because that's easier to deal with at the end. Okay, this is a 2 by 2, and this is a 2 rows by 1 column. So these numbers are the same. That means it's possible. These outside numbers, the 2 by 1, means that's going to be the dimensions of our new matrix. So we have 2 rows and 1 column. So first row, first column right there. Here's the first row. Here's the first column. Negative 8 times 0 is 0. And then negative 3 times 30 is negative 90. So we'll simplify that in just a sec. Okay, then the second part of it would be second row, first column. Here's the second row. Here's the first column. Negative 6 times 0 is 0. And then negative 1 times 30 is negative 30. So when we simplify this, just going to move it up for a second. When we simplify this, 0 plus negative 90, 0 plus negative 90 is negative 90. Okay, and then 0 plus the negative 30 is just going to be negative 30. So we have negative 90 right there, negative 30 right there. Negative 1/10 gets distributed to both of those. And our final answer, negative 1/10 of negative 90 is 9. And negative 1/10 times negative 30 is 3. So that is the solution. That's matrix A that we were trying to find at the beginning. And if you want to test that out, 9, 3, you could very easily test it out. You could just plug in 9, 3 right there for A and multiply it by this matrix, and you would get 0, 30 when you check it. All right, so see if you could pause the video and try number 2 as well. It's a slightly harder example, but the same method applies. All right, so hopefully you had a chance to find that. Again, let's call this matrix X because we don't know what it is. We need to find X inverse so that we can multiply both sides by that, make those cancel, and find out what C is. So let's start by finding X inverse. It's 1 over the determinant of this one. So the determinant is going to be negative 2 times negative 2 is 4 minus 2 times negative 2 is negative 4. 4 minus negative 4 is like 4 plus 4, which is 8. So 1 over determinant will be 1 over 8. Then we switch the first diagonals. So negative 2, well, obviously those are the same when we switch them. And we negate these. If we negate negative 2, it's 2. If we negate that 2, it becomes negative 2. So this right here, this whole thing, that includes the 1/8, that's our inverse matrix. Now we need to do this multiplication right here, X inverse times that other side, because that's going to give us what we're looking for, which is matrix C right there. Okay, because remember these on the other side have now canceled, leaving us with C, and that's what we're trying to find. So this is a 2 by 2, that's a 2 by 2, so we certainly can multiply them. We're going to get a 2 by 2 as our answer. And it's usually always easier to leave that 1/8 outside for the end, so that's what I'm going to do, just to keep it simple. Okay, we have right there, that's the first row, first column. So here's the first row, here's the first column. Negative 2 times negative 24 is 48. 2 times negative 12, that's right here, is negative 24. So there's our first entry. This right here, let me just make this a little bit bigger so we can expand it out slightly. Okay, so the second, or the next entry I should say, is going to be right here, which is first row, second column. So here's the first row, that's not the second column, that's the second column. Negative 2 times 4 is negative 8, and 2 times 0 right here is 0. Okay, then at the bottom we have second row, first column. So here's the second row, here's the first column. Negative 2 times negative 24 is 48. Negative 2 times negative 12 is positive 24. And then here's our second row, second column. So second row, second column, negative 2 times 4 is negative 8. And negative 2 times that 0 is 0. So let's just clean this up a little bit. So we have 1/8 times 4, and then this number right here is 24. This number and this number are both negative 8. And the last number right here is 72. So our final answer, okay, this is a drum roll because it's the end of Unit 3. You now know most of what there is to know about how to solve systems in Algebra 2. Our final answer will be taking 1/8 and distributing it to each thing inside here. And that's going to be the following. 1/8 of 24 is 3. 1/8 of those two negative 8s would be negative 1. And then 1/8 of 72 is 9. And that was matrix C that we were trying to solve for. So now you've hopefully achieved the goal of being able to know a lot more about how to solve systems of equations, and also dealing with a new thing that you generally don't see in other math classes, matrices and various different things that you can do for that. So that's the end of Unit 3. In Unit 4, we'll move on to a topic called quadratic equations, which is a very important topic in Algebra 2. So hope to see you there.